All right. We're going to fly through some of these next ones because they're pretty quick to go through. You can use the fundamental accounting principle with more than 2 groups. We've only talked about 2 groups thus far. You can do more than 2 groups. And luckily, it doesn't actually change too much when you do more than 2 groups. It's still going to be multiplication. You're just multiplying by more things at this point. So when you're doing the definition for a fundamental accounting principle with more than 2 groups is the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. Same thing, except for there's more of them. So when we're looking at this one here, they give us the possible number of outfits for 2 pairs of jeans, 3 t-shirts, which we had that amount before, but now they add in 2 pairs of sneakers. So they show the diagram, because they're using fairly small numbers here. We had this piece before, we had the pants. When you add in the shoes though, they branch again off of each of those options. So since this is a fairly small number, that bottom, these show all of the different combinations. And if you add them up, it would end up being 12. Same thing here. If you do 2 times 3 times 2, you're also going to end up coming up with 12. So there'd be 12 options if we added sneakers to it. Any questions about these thus far? Okay, I wasn't expecting too many questions. All right, so flip this over to the next page. The next page, there's a couple of things that get a little bit trickier. And it's not the math itself that gets trickier, but it's making sure you're identifying things correctly. And really the first one here isn't too crazy. The example says, next semester you're planning to take 3 courses, math, English, and humanities. There are 6 sections of math, 5 of English, and 4 of humanities that you find suitable, assuming no scheduling conflicts. So conflicts are going to come in later in this section where you're going to have to remove some things. But in this case, we're assuming no scheduling conflicts. How many different 3-course schedules are possible? What am I going to do to find that? Yep. 8 times 5 times 4. What'd you say it was? 160? I'm pretty sure you're right. I haven't done this for 2 years, but that sounds right to me. So there are 160 possible schedules, which is actually a fairly large amount considering we were talking about only 8 sections of English, or of math, 5 of English, and then 4 of humanities. All right. Like I said, I'm kind of flying through these. If you need me to stop for a second and you have a question, please let me know. The last one on here is the one that gets a little bit different. The next example has, you're taking a multiple choice test that has 10 questions. Each of the questions, it's that one there. Each of the questions has 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, how many ways can you answer the question? This one's a little bit different. Does anybody have any idea of how we actually find this? How do we find how many possible ways we can answer the questions? Any thoughts? There's a few people looking at your phones. If you're looking at your phone, please put it away. Because this one, almost everybody gets it wrong the first time they do it. Okay, so I'm actually glad you mentioned this. It's not, but that's actually what I was looking for. So based on what we've had before, we're told that we have 10 questions with 4 options. So the automatic reaction for most people to do is to go 10 times 4, which would obviously give you 40 ways, right? You'd have 40 ways. Now, that's wrong, but based off what we've seen thus far, that makes sense, right? Because we're just multiplying things together. So here's what's tricky about this, is that you have to think about each question as its own thing. So, for instance, when we were talking about, I'm going to write this off to the side here. On the previous one, we had 8 sections of math, 5 sections of English, and then 4 of humanities. Each of those was their own separate piece, right? That had their own amount of options. On this, we actually have each question has its own amount of options, right? It has 4 options per question. So what you're actually talking about is 10 questions that have 4 options each. How many do I have on there? Need 2 more. So that's your answer was exactly what I was looking for, because this question leads you to think that's kind of what it is. But what you have to think about is that each question is its own individual thing that has its own options with it. They're the same amount of options on each one, but each one has its own options. So it's actually 4 times 4 times 4, 10 times, or you could write it out as 4 to the 10th power. And that's why I want people to be paying attention, because this one almost always gets messed up if somebody is not paying attention during the notes. So, plugging that into the calculator, that gives you, so 4 to the 10th gives you 1,048,576 options. So, something that's important to remember about this. So just in 10 questions with 4 options, there are over 1 million different ways to answer that test. Over 1 million. The other fun thing to think about this is that only one of those options is 100% correct. So if you go into a multiple choice quiz, even one that's only 10 questions long, and guess on it, you actually have a 1 in a 1,048,576 chance of actually answering every single thing correctly. Something to think about. Your chances aren't great. Any questions about that one? Because that one's a little bit different and you have to think a little bit more on it. So be careful. Be careful if they're talking about questions or things that have their own options. In this case, they mentioned that there's 10 questions, but each of those questions has its own 4 options. So if each of those things has its own options, that's when you have to spread them out like that, and you're not just doing the 4 times 10. So I'm going to actually cross this out. Make sure, if you wrote that down, cross out, because it's not the correct way to do it.